Now that we know what triggers an electric current, what is an electric circuit, and the three effects of electric current, that are heating effect of electric current, chemical effect of electric current, and magnetic effect of electric current, let's look into detail to understand what is magnetic effect of electric current. We know that the scientist Hans Christian Ørsted accidentally discovered that electric current could cause a compass needle go haywire. That means it gets deflected as long as a conductor, a wire, carries current. He discovered that moving charges create magnetic field. Thus, children, in 1819, this famous scientist named Ørsted found out that if we keep a compass needle near a current carrying conductor, that is a wire, then the needle of the compass gets deflected to some extent. Yes, understand this well. When current passes through the wire, the magnetic needle gets deflected. Why? Why does this happen? Because the current produces a magnetic field around it, or we can say that the wire behaves or becomes a temporary magnet. So, children, Hans Christian Ørsted was the first person who noticed that the deflection of compass needle every time was caused due to the current that was passed through the wire in a closed circuit. So, when electric current passes through a wire, it behaves like a magnet, and this is called as magnetic effect of electric current. We know that this current carrying wire or conductor behaves like a magnet, due to which the magnetic needle gets deflected. But how long will this happen? This will happen only till the current is passed or is passing through the wire. That means the wire behaves like a temporary magnet. We know that there are two types of magnets: permanent magnets and temporary magnets. What are the differences between the permanent magnet and the temporary magnet? Let's look into detail. A permanent magnet does not lose its magnetic properties easily, but a temporary magnet loses magnetism when the current is switched off. Permanent magnets are made of steel. Temporary magnets are made of soft iron. Permanent magnets do not depend upon the electric current for their magnetic force, but the temporary magnets get magnetized only when the current is flowing through the wire. Thus, children, let's understand now what is an electromagnet. An electromagnet is caused due to the magnetic effect of electric current. When electric current is passed through a coil of insulated wire around the soft iron bar, the iron bar behaves like a magnet. But which magnet? It behaves like a temporary magnet. This is called as magnetic effect of electric current. And the magnetic effect disappears as soon as it becomes an open circuit. Thus, children, let's understand in more detail. Take a flexible copper wire having a resistive coating and wind it tightly around a long iron screw. Connect the two ends of the wire in a circuit as shown. Also connect the electrical cell and a plug key in this circuit. Let's keep few iron pins, small nails near the iron, to understand how the iron starts behaving like a temporary magnet. Now, close the switch so the path becomes closed. Now the current in the circuit starts moving by closing the key. It will be noticed after some time that these pins or nails get stuck to the tip of the screw, that is the iron rod. Will the pins or nails continue to stick when the plug key is opened? No, definitely not, because it becomes an open circuit and the current ceases. When the electric current flows through the wire, magnetism is produced in the coil around the screw, and because of that, the screw also attains magnetism. And how can we see it? Because of the iron nails getting attracted towards it. As soon as the current is stopped, this magnetism vanishes. The system of coil and the screw is called a electromagnet. We have seen various uses of electromagnet, children, in the earlier classes. Electromagnets are used to produce strong magnetic field useful in scientific research. So thus, this is how an electromagnet is produced and how it works like a temporary magnet. So thus, children, if this is the nail, this lines show us the magnetic force or lines of magnetic force which are produced as long as the wire is a conductor and current is flowing through it. Thus, children, to sum up with, what are electromagnets? An electromagnet is a type of magnet in which a magnetic field is produced by an electric current. The magnetic field disappears when the current is turned off. Electromagnets usually consist of a large number of closely spaced turns of wire or coil that create the magnetic field. So here we can see the lines of force of magnetic field produced when the wire is a conductor. That means it is carrying current. Let's look into the detail of uses of electromagnets. They are used in home appliances like electric doorbell, induction cooker, magnetic locks. In medical fields for MRI scanning, they are used in memory storage devices and computer hardware, as well as they are used in communication devices and power circuits like in mobiles and telephones. So children, let's understand the relation between electricity and magnetism. What do you do when you reach your friend's house to tell him or her that you are at the door? You ring the bell, isn't it? Do you know what makes the bell ring? An electric bell also has an electromagnet that pulls a strip of iron which makes the hammer hit the gong to ring the bell. So, let's understand the working of an electric bell, the construction of an electric bell. So, what is an electric bell? An electric bell is a device in which to and fro movement of a hammer on the gong produces the sound of bell. It works on which principle? It works on the principle of magnetic effect of electric current, that is electromagnetism. It is an important application of an electromagnet. So we can see an electromagnet placed over here, which is used in offices, houses, schools, as well as alarm equipment, etc. Let's understand in detail the construction of an electric bell. It consists of a U-shaped electromagnet in front of which is a soft iron strip, or you can also call it as an armature supported by a spring. The spring is connected with an adjustable contact screw. An iron hammer is attached to the armature or the iron strip, which can move to and fro depending upon the movement of the iron strip. The armature carries at its back a strip of flexible steel which is in normal position, which remains in contact with the screw. A metallic gong is fixed to the baseboard and a hammer striker may strike on it. One end of the coil of the electromagnet is connected to a terminal and the other with the spring, which through the adjustable screw is connected to the other terminal. When the terminals are connected to a battery that we can see and the switch is pressed, the current flows through the contact points. That is the electromagnet, which makes the electric bell work, and we hear the sound of the bell ringing. So this was the construction of an electric bell, the parts of an electric bell. Let's understand the working of an electric bell. So to begin with, children, let's understand the first. Current flows through the electromagnet when the switch is closed. When the press button or the switch is pressed, as you can see over here. So when the button is pressed with our finger at the door, the current flows through this electromagnet. That is the first step. Let's move on. What happens to the soft iron core when the current moves? The cores in this electromagnet, or you can call it as a solenoid, becomes an electromagnet because the current is flowing through it. This shows, or we have already seen, the magnetic effect of electric current. What happens when this starts behaving like an electromagnet? Then the soft iron armature, which is attached to this electromagnet, gets attracted towards the magnetic iron cores and disconnects itself from the contact screw. So when the electromagnet starts behaving like a magnet or a temporary magnet, this soft iron armature gets attracted towards the magnetic core and it gets disconnected from the contact screw. In turn, what happens? The hammer goes and strikes the gong very quickly and it produces sound, that is the sound of the bell, due to which we can hear. Now, when this contact is got disconnected, it becomes an open circuit and no current flows. So, the iron does not behave like an electromagnet. It loses its magnetism. As soon as this happens, once again the soft iron armature returns back to its original position and the circuit is closed. It becomes a closed path again. The electromagnet of the electric bell is the main part which repeatedly switches itself on and off very rapidly till you go on pressing the switch of the electric bell, and this in turn makes the bell ring continuously. So this, children, was the working as well as the construction of an electric bell. So let's recall the working of an electric bell. As we can see over here, this shows you the internal parts of an electric bell. Let's again understand the working. When the current is passed through the circuit, when you press the key or the switch, the electromagnet acts like a magnet, due to which it attracts the iron strip towards it. Because it starts behaving like a magnet. It gets its magnetic properties induced in it. And the iron strip, being elastic, comes and strikes the gong, and we hear the bell. Simultaneously, what happens is the contact of this striker is lost with the contact screw, and the circuit breaks and the current stops because it becomes an open circuit. As such, the iron strip returns to its original position, and again the current passes through the electromagnet. This phenomenon happens many times in a second, and as the hammer strikes the bell, the sound is heard. The bell rings till the circuit has been switched off. The electric bell is used in alarms and bells in schools, offices, homes, and industries. So, this concludes with the construction and working of an electric bell. This shows us the main effect of magnetic effect of electric current.